Hey everybody, in this video I'm going to be looking at this FSP power supply. This is the power supply that come out of that $15 computer that actually booted into Windows XP. This power supply was the only reason that computer would not start up originally. After I swapped out this power supply and hooked up a different power supply, the computer started right up. And here's exactly what happened with this power supply. The fans would spin and the power LED on the computer would flash, so obviously there was something wrong. And it wouldn't surprise me a bit if there was bad caps in this power supply. And this is a proprietary design unit. This isn't your standard ATX unit. The wiring is standard ATX, but the form factor, the shape of it is not really standard. It's kind of like a micro ATX unit, but it's a bit fatter from this side to this side. Lengthwise, it's pretty much the same. So let's go ahead and pop the cover off and have a look inside. And here's something real funny. Before I actually begin, if you guys remember back on that video where I recapped that Hyper power supply, where I actually put electrical tape around the wires, well, FSP has done something similar from the factory. They put this little felt around the wires to protect them from the metal casing. So that's definitely a good thinking there. Okay, here's that power supply all torn apart. I decided not to include the video of me actually tearing this thing apart because it was really a pain, you know what, to get it apart. Anyways, let's go ahead and have a look at the quality of this power supply. We've got passive PFC. Of course, it's not active PFC, but it's still better than no PFC. There's a big coil, and it's a heavy one too. Here's your fan. It's a ProTechnic electric, possibly a ball bearing. And the date code on it is July 25th, 2008. So this power supply is only about 4 years old. So obviously the computer is about the same age too. The computer would be actually newer because, of course, the components like the power supply manufactured and shipped to MSI, and then everything there was assembled. So anyways, that computer is about 4 years old. The $15 part system that booted the Windows. Anyways, this is another example of FSP overbuilding their power supplies. This is rated for 250 watts, but we have some really good quality components in here. The brands, the capacitors are not very, I don't really care much for, but we do have 680 microfarad caps on the primary side. Your average 250 watt power supply would usually have 470 microfarad caps there. Go ahead and turn this thing around. Look at the filtering stage, which is located on this little PCB. We have 2 X capacitors, what appears to be 3 coils, 2 Y capacitors that are mounted to the AC receptacle. Have a little bitty fuse there on the corner, and there is, next to that is a connection where the AC comes in from the switch. And this is the first time I really even took apart a power supply and really looked over a unit with passive PFC. So go ahead and have a closer look at the spec level since I didn't include that earlier. Pause, view specs. So yeah, this is a fairly well built unit. 16 amps on the 12 volt rail. That's actually more amperage than what a Bestech ATX 312E puts out on its 12 volt rail. Just to give you an idea. So yeah, 16 amps on the 12 volt rail. And it's funny, 16 amps all along, plus 5 volt and plus 3.3 volt, all 16 amps. And let's go ahead and just peel this label off here. Try to anyway. I think the PFC coil is mounted with screws under that. Now, of course, in a future experiment, I wouldn't mind actually trying to mount that PFC coil inside of a power supply that had no PFC at all. I noticed the coil has 3 wires coming out of it. It has a blue, a white, and a black. I'm assuming the black is likely to be a ground wire, though I'm not exactly sure. I'd have to figure out how to wire it up. So yeah, let's go ahead and cut the wires to that PFC coil so I can get it out of the way. Now, of course, if you guys are new to power supplies and don't know what's better, active PFC or passive PFC, active PFC is much better. It's the newer technology. That's one wire. Let's see here. I'll just cut the wires right about here. Get there as far as possible. And same goes for the white wire. Get rid of the zip tie. Gotta love these things. Let's free up the wires. And there's our PFC coil. That thing probably weighs maybe a pound or two just by itself. Now, going to continue looking. I'm going to be saving, of course, the fan, the PFC coil, and the filtering stage components, the primary filtering stage components. I'm just going to get rid of the rest. I don't really care much for TPO capacitors, and we do have a bulging TPO cap on this unit. And I think that was the one that caused our failure. Let's bend these wires that way so we can have a look. It is right there. We got, well, actually we got two bulging TPOs in this unit, and those were what caused the failure. The power supply still powered on, yet the computer didn't really appreciate the power it was getting. Probably had a lot of noise, and probably, I guess, maybe the 5-volt line or the 12-volt line, whichever, or maybe the 3.3, not sure whichever one these caps were responsible for. So anyways, I'm going to continue looking. Just going to try to get some general idea on this, on the components in this unit. Our bridge rectifier is a GBU605, probably a 6 amp rectifier, judging by that model. I'm going to grab a paintbrush so I can dust off those components and have a look at them. Of course, I didn't bother to blow this unit out before I opened it. That's why there's still a bunch of dust in here. Just run this paintbrush in here real good. Dust off the main switchers. I can't really see the rectifiers, I mean the models on the rectifiers, so I can't really tell you what's what on those. I might be able to tell you some. You see our main switchers, we have two E13009Ls. And let's see, for the secondary rectifiers, let's see what we have there. Can't really tell what we have down here because most of the stuff is so blocked off I can't really see it. But anyways, let's go ahead and pop this off of here. Okay, here's another look at that little PCB with the primary filtering stage. We also have our inrush current limiting NTC thermistor there. And of course, all these components come useful for me because I can reuse these. Instead of cheap power supplies or any power supply that needs these components. And we're going to snip the wires to our fan. Where are my dikes? I say it's a pretty nice fan. It'd be nice for a small form factor power supply that needs a narrow fan, or it could be used as a case fan or whatever. Now let's go ahead and finish up this video by taking off that PFC coil. And as you notice, I did things the easy way when it comes to tearing this thing apart. I just bent the clamshell piece wide open. Makes things a whole lot easier. Now let's go ahead and take that PFC coil loose. One thing I enjoy to do, I like to tear down power supplies. Just for the fun of it. Yeah, I believe this PFC coil will fit in pretty much any case that has the screw holes available. I'm gonna try to reuse this in another power supply. Just gotta figure out how to wire it up. That's what we got Google for, so yeah. Alrighty. There's our PFC coil. Had some really thermal transfer material there. This right here, I'd say probably weighs at least a pound or two by itself. This is why those power supplies, the older power supplies with PFC, are so dang heavy. It's this coil. This thing is pretty heavy. It's like, it looks like a giant, well, I can't say giant, but it looks like some sort of transformer. A lot of people get these confused as a transformer. They're just a series coil, if you want to call it that. I think, anyway, I think this black wire is a ground. I may be wrong. And of course, your power supply experts out there, correct me if I'm wrong. Tell me how this works. Anyways, yeah. That's the inside of that FSP model. FSP 250-50 MSP. So anyways, if you have any questions or comments, feel free to ask them. Thanks for watching.